Vanessa and Corey are a happily married couple with an income of $90,000 and full insurance coverage. They decide that that's just enough money for starting a family and give birth to their first child, Shay. However, Shay was born with X-linked ocular albinism. As Shay grew, it was clear that her vision was impaired. This led to difficulty while learning fine motor skills and reading. However, Vanessa and Corey were not deterred and had another child named Nicole.
Nicole was born with another type of albinism called OCA2.
As Nicole grew, she had impaired vision as well, although not to Shay's degree. OCA2 albinism, due to a massive lack of melanin, gives UV rays an open target. Corey and Vanessa, adoring their roles as parents, decide to bring another little bundle of joy into the family, but they'd like to know if their next child will end up with any form of albinism. They decide they're going to see a genetic counselor to determine whether or not their next child will have albinism.
It's time for everyone's favorite part.
The boring part!
Right out the gate, we're going to cover the pedigree. The square is the father and the circle is the mother, as has been established before, to be Corey and Vanessa. Their two offspring are their two daughters, Shay and Nicole respectively. Oddly enough, the mother is the one with the trait for X-linked ocular albinism, although it's very rare in females. This is passed down to Shay and remains in the genetics of Nicole. Both the father and the mother have genes for OCA2, which is passed down to Nicole and remains in the genetics of Shay. Next up, the Punnett square. These are all of the genes for OCA2. OCA2 only presents in offspring when the offspring have homozygous recessive traits. Seen on the Punnett square, this only has a 1 in 4 chance of occurring. Next, the X-linked ocular albinism genes. This was a bit tricky to present on a Punnett square, since the mother has a 50% chance of passing it to her offspring regardless of other genes involved. This was best represented on a Punnett square through making all instances heterozygous.
Your probability for a child without albinism is roughly 50-50. You could give it a shot, but be prepared just in case. Get out of my cave.
Hopefully, their next child will not have albinism. Their newest addition to the family, Michael, does not have any form of albinism.